Welcome back to our heat transfer class, where we are delving into the use of numerical methods for solving heat conduction problems within solids. This video was made with the support of InnoEnergy. After the calculation of temperatures and heat transfer rates in a steady state, we are studying the system of equations for the transient regime, its resolution, and the analysis of results. Remember that this lesson is divided into several parts. This video is about parts 5 to 7. In the previous video, we developed the system of equations in the transient regime. Now it is time to learn how to solve it. For the solution of the system of equations, we will use the matrices method. Recall how the system of equations for a steady state was solved using matrices and vectors. The advantage of this method is that these matrices and vectors can be used when solving the transient regime. Recall also the expressions of the conservation equations for the implicit method and for the explicit method. For the explicit method, the expression of the unknown temperature at time n+1 is a function of known parameters. We call Tf the vector of the temperatures at the instant n+1, and Tn to the vector of temperatures at the instant n. Gv is the vector of the internal heat generation in each domain. dTc is the matrix that contains zeros except for the diagonal terms, which are the delta T divided by the heat capacity of each domain. The heat exchanged with neighboring nodes has the same matrix structure used in the steady state. This is finally the formula for calculating temperatures for the transient regime using the explicit method and the matrix method. It can be seen how the temperature in node I depends on the neighboring nodes, the bordering nodes, and its own internal heat generation. For the same amount of energy input, the temperature of the node will evolve in the transient state faster or slower, depending on its heat capacity C. Let's now analyze the utilization of the matrix method with the implicit method. Terms in the energy conservation equation for a generic node in using the implicit method can be rearranged, giving as result the expression of the calculation of temperatures during the transient regime using the implicit method, which is a little bit more complex than that for the explicit method. Summary of advantages and drawbacks. Let's summarize the advantages and drawbacks of both methods. For the explicit method, there is no need to solve the system of equations. Temperatures can be calculated one by one. On the other hand, the implicit method requires solving the system of equations at each instant to calculate the next temperature vector. The explicit method is not unconditionally stable. There is a maximum delta T that guarantees the stability of the mathematical solution. The implicit method is unconditionally stable. If you want to use a short time interval to have better accuracy, the explicit method is easier to manage. If you want to have an approximate solution calculating very few intervals, the implicit method allows using longer time intervals without stability problems. Energy balance in an interval of time. After calculating temperatures, you can calculate the heat transfer rate at each instant. For an instant n, the heat transfer rate for the solid with the boundary node Ni+1 is the sum of the conductances of the solid nodes with the boundary node times the temperature difference in this instant n. The only difference with the steady state is that there is a different value of the heat transfer rate at each instant. The energy balance in an interval represents the variation of internal energy between the initial instant and the final instant. In both methods, this is the sum, for all domains, of the product of heat capacity and the difference in temperature at the final instant and the initial instant. To fulfill the energy conservation principle, the stored energy during this time interval must be equal to the sum of inputs of energy plus the energy generated minus the outputs of energy. Because the energy balance is made in different instant for explicit and implicit methods, the mathematical expression will be different. For the explicit method, inputs, outputs, and internal heat generation are evaluated in the instant n. And for the implicit method, inputs, outputs, and internal heat generation are evaluated in the instant n+1. Wrapping up. The energy balance method consists in using a discrete physical model of the solid under study. In each domain, temperature, properties, and internal heat generation are assumed to be uniform. The system of equations is derived from the application of the energy conservation equation in each domain. The finite differences method allows to find the evolution of temperatures over time in a transient regime. Because the derivative can be approximated by a difference in several different ways, there are several methods for solving the transient regime. The key question when solving the transient regime is, in fact, not how the derivative is substituted by a difference, but what temperatures should we use to calculate heat inputs and outputs. In the explicit method, inputs, outputs, and internal heat generation terms are evaluated at time n. This is equivalent to approximating a continuous function by a step function below the continuous curve. An undesirable feature of the explicit method is that it is not unconditionally stable. In the implicit method, inputs, outputs, and internal heat generation terms are evaluated at time n+1. This is equivalent to approximating a continuous function by a step function above the continuous curve. The implicit method has the disadvantage that the system of equations must be solved at every time step. The advantage is that it is unconditionally stable, that is, it does not have a maximum delta T like the explicit method. This does not prevent that the larger the delta T, the larger the error you make by approximating a derivative by a difference. Like the steady state, the transient regime can be solved using the matrix method. For the transient regime, it is needed to define the matrix dTc and two different vectors for temperature. This is the expression for the explicit method. For the implicit method, the expression is a little bit more complex. However, matrices and vectors are the same than for the explicit method. Each method has its advantages and drawbacks related to their complexity and the stability of their solutions. This makes each method more suitable depending on your needs. Regarding the energy balance in an interval, for the explicit method, inputs, outputs, and internal heat generation are evaluated in the instant n. And for the implicit method, inputs, outputs, and internal heat generation are evaluated in the instant n+1.